So thank you. This is great. I'm excited to be here. I'm looking at the companies that are on the list here from all over the place and lots of different types of companies. And I definitely want to make this an interactive kind of process here because I think I can learn from you in the same way hopefully you can learn from me. I have a broad background in big companies and small companies, startup companies, well-established companies, companies that build product in-house and externally. The themes are the same in all those companies. A lot of the things the good things and the bad things about hardware ramps are true for both startups and big companies. But for startup companies, the stakes are higher. So I titled this, delays and debacles. Both are pretty difficult for startup companies because time is money. And it's so important that startup companies make fewer mistakes so that they can ramp successfully without tripping over items that might delay their introductions or might cost them too much money, which we all know is a bad thing when your capital is limited. So today what we want to talk about is maybe the less difficult problem of delay and the more difficult problem of a debacle or a disaster. But the themes are the same really in the two. I'm going to talk about what not to do, and then we'll kind of summarize at the end what to do to kind of avoid those things. But to start out, does anyone know about this guy? You read about him in the paper? Or is there paper anymore? On the internet? This guy climbed El Capitan solo without any safety equipment and basically no ropes, walked up to the bottom of El Capitan with grippy shoes and a little sack of chalk and started climbing a week ago Saturday. Got up early, started 4 hours later, he was at the top. This guy's brave. He's got a lot of chutzpah. Don't do what this guy does when it comes to hardware ramps. So we're going to talk about kind of how to do it more safely without the risk. Hooray for Alex, but don't do that. So before I kind of get into the material, can I hear how many of you are in companies that are shipping a hardware product right now? So about half of you. And how many of you are in companies that plan to ship a hardware product? The rest, the other half. Okay, good. And I assume that the ones that are shipping, are you in early stage or are you on your second product? Kind of what's the makeup of the types of products that you're shipping?
As it's the first product in-house, we already have a hardware, but it was developed outside, and now we're doing it.
Brought it in-house. Good. Okay. Any other stories?
Our company, we have, I guess, 3 products now out, and we're working on another 3.
Okay. So you're kind of beyond the first generation.
Yeah.
Great. Yeah. So there's different kinds of problems you're going to run into depending on the life cycle stage that you're in as a company. And we'll try to cover all of those things. Feel free to chime in with examples or questions or comments. Well, like I say, try to make this as interactive as we can. So we're going to talk about hardware ramps and the good, bad, and ugly of those. They're never problem-free. We'll be surprised when you start. It isn't going to be as you predicted. They're typically more expensive than you think when you start, and they'll take longer. And the bad news is that they sometimes can tank your company because it's a very expensive proposition to launch a hardware product. The good news is that it's a lot of fun and it can result in a great business, and we heard about some of those examples today. Startup companies are not, they don't have a great track record of being successful, and I think I've heard numbers like 75% or even 90% fail, depending on how do you describe fail. Hardware startup companies, I think, are even more difficult than that. On the other hand, I think there are great examples of successful hardware companies. We heard some of those examples today. Fitbit certainly. Flip Video is the is a very successful startup company that was purchased by Cisco. There's some companies on this list here, maybe represented here today, that True Venture has sponsored, has funded, and they have, I would say, they've had success. Certainly Hatch Baby, you're shipping product, and that's a success. So it's not gloom and doom, but I do want to kind of alert you to some of the challenges and the consequences of those challenges. So we're going to go through delay and debacle. The first is delay. I'm going to talk about 4 things that cause delay. One of those is sort of the self-inflicted issue. Second one is supplier generated. We'll spend some time on that because that relationship with the contract manufacturer is probably one of the most difficult ones that you'll work through. Unrealistic scheduling. I'm sure none of you have ever done that, but it has been done. And then the final one is the remote control management issue. So don't be like Elmer Fudd here. Self-inflicted kinds of problems are ones that typically start before you even build product. So the self-inflicted kinds of problems are typically caused when an engineering firm, engineering company is just thinking engineering and isn't thinking of productization. So the best way to avoid that is to do concurrent kind of development, and we've been taught that it sounds good. It was all the rage, but it's very difficult as a startup company to feel good about investing in anything but development when you first start. You can easily do that though with the right kind of mentality and leadership, and I think that's what I want to try to emphasize. Getting your feet under you, so to speak, from an operations point of view, before you even start to talk with the manufacturing company is the way to go because it will save you much time later. Kind of the key issues that I've seen is companies that don't really document. They figure that they can either do it kind of in their CAD systems and their BOMs are in an Excel spreadsheet, but they don't really have part numbers, and they figure that the supplier can do all that. When I see little grins out there, I'm wondering if you've been through something similar. The challenge with doing it that way, of course, is that you have a hard time communicating then with your supplier, and you don't know where you stand. Kind of jumping down to the last one in the list here. If you don't have it well documented, it's very hard to control that design. And having your product under some sort of a rev control is critical as soon as you bring in one more entity. Because you want to make sure that they are building what you want them to build, and that they are not, and they don't have permission to change without your agreement. And that ECO control is so important. And I've seen companies, a couple different companies, actually fail because their contract manufacturing partner decided that it wasn't no big deal really to go out and change a part to a different supplier. It was going to save them some money. We'll get to why they do that sort of thing in a minute. And they change that one component, and the product doesn't work or isn't reliable, and the company, has to regroup and start over or fold. And so there can be some pretty major catastrophes that come out of not having your product in control. The second bullet here, screwing up NPI, has to do with kind of not being honest with yourself. So a lot of companies start out with a product, they think it's good enough. They can build it in the lab, and then they find out as they start to build at the contract manufacturer that they have to make some changes. There's major kind of revisions that are required to make the thing work in a customer environment or in volume. And so they go through an EVT1, an EVT2, an EVT3, or a DVT1, 2, or 3, and sometimes a combination of the two. It's much better, by the way, if you're going to pick one of those two, to have revisions in your EVT than to go out to your contract manufacturer, think you got a design that's finished, that's complete, and then start revving, because that's a lot more expensive. You've got a whole supply chain now that you've got to control, and that adds to scrap and other issues that come up. So try to avoid both, but certainly if you're, if you have to iterate because you are learning some things as you go through your engineering verification, stop, make those changes, re-verify, wait till your design is done, and then go do a design verification with your contract manufacturer or in-house if you're doing it in-house. And the third bullet here, not buildable or testable, that's sort of an obvious one, but you want to make sure as you're designing that you can test the product, and that's maybe one of the biggest challenges I've seen where a product is designed, but the engineering team didn't think about how it was going to be tested in volume, especially when you're talking about a volume product. Having those hooks in the design are very critical for kind of low-cost testing and rapid testing. Without those hooks, without that early thinking about how to build it, making sure it's manufacturable, you'll end up with a product that costs too much and that maybe can't be built at all or can't be built with quality. So the second one, supplier generator, we'll spend a little bit of time on this one because I think it's the house made out of straw. It potentially can be. A contract manufacturing relationship is kind of like a marriage. If you don't have a good marriage, you don't have a healthy home. Without that good contract manufacturing relationship, your ramp is going to suffer, and your NPI house, so to speak, is not going to be very healthy. Just a few, I've seen companies launch forward with a relationship with a contract manufacturer without any kind of contract in place. And the reasons are that we have a good relationship. We've talked about a lot of things. Their cost is good. We're just starting. We're not ready for a contract. And I'm not talking about a heavyweight, many hours of negotiation kind of contract. I'm talking about getting the basics in place. Eventually, you want to have an MSA. Maybe you start out with a letter of intent, but you definitely want to talk about what could go wrong and who will do what before you get too far into the process of this quote-unquote marriage with your contract manufacturer. It's a whole lot easier to talk about those things before they happen than after they've happened. Examples are, who's going to own the material? At what point do you pay? Do you have to pay up front? Do you pay 30 days after they ship? Makes a big difference from a cash flow point of view. Who is responsible for the process design? What is their responsibility for purchasing material? Do you want them to take some liability and go forward and purchase some of those long lead time items so you have upside flexibility? Talk about those things up front. Then, staff correctly. So not being properly staffed is equally as onerous, both from the startup company's perspective and from the supplier or contract manufacturer perspective. You want to make sure that they're putting their A-team on and you've got resources on your side to interface with that company. You want to make sure that there is a clear path of communication and that the person on their side or persons on their side have their fingers in the right places and their ears in the right places to know what's going on within that company. And a lot of times, you're a little startup company, it's hard to get that A-team. We'll talk a little bit more about how you do that, but you want to make sure that they've got good people on their side. If they've got the C-team, you'll be hurt badly as you go through this process of ramp. Pay attention to your parts. If you ignore if you haven't documented and you don't know your lead times, you don't understand your bill of material, you may find out that you've got a long lead time, 16-week kind of part on your BOM, and now you thought your schedule was all about starting in 4 weeks, and you've got to wait another couple months, or you have to expedite like crazy and buy on the gray market, and lots of downside to that as well. You want to make sure when you're negotiating with your supplier that you understand who has the responsibility to buy and out how far. Do you want them to buy to forecast? Do you want to just authorize for the next build? Do you want them to take some risk positions on material? And don't pick a supplier or contract manufacturer that doesn't know what they're doing in your space. So if you build teddy bears, if that is your product, if you're a startup company that's a teddy bear startup company, this would be a great supplier. If you're a camera company, don't go to a supplier that's building toys. If you're a toy company, don't go to a supplier that's building high-end electronic computers and doesn't have any experience in your area. You can ask a lot of questions. You can get references. You can talk to other companies who have used that CM, find out what their experiences are, tour their line. Make sure that you understand, what kind of engineering capabilities they have, because what they are lacking, you will have to fill in with, and that costs you money and sometimes time. So this is just a little kind of education on contract manufacturing, and many of you who've already launched probably get this. But this business model is a really difficult one. Contract manufacturers are running on razor-thin margins. They are struggling in whatever region they're in with labor costs and material costs, and those things are a bit unpredictable. And in China, they're going up and to the right. Picky customers, pushy customers are even more demanding than they used to be. A lot of startup companies are coming after these CMs to get service, and they've got to figure out which of those companies to work with. They can lose their profit for the year on one bad quality mistake. They can lose their profit for a year with one company that goes under and can't pay their bills. They have a huge problem in many regions with turnover. So Chinese New Year, you've probably heard this story. Everyone goes home in China, and 30-40% don't come back. So they're always trying to hire ahead of that and try to understand kind of what their return rates are. But that's a big risk to those companies, and something that we just don't even think about here. We end up being irate. How many stories have you heard of wonderful relationships with contract manufacturing? And I just love them. And I think those are just they're not around. I can say there are some contract manufacturers that I like better than others, but every single one that I've worked with has its challenges. And it's not their fault, so to speak. It's just their model is very difficult. So their challenges that oftentimes the individuals that you're working with are understaffed. The company's understaffed. The people are overworked. So what do? How do they survive? Well, they wring every single cent out of their business, and they look for ways of making money kind of right and left with, the volume pricing, and then they don't pass those savings on. So they may have 3 companies that are buying a specific component. They go get that volume price, and then they only pass on to you what the price is that was for your quantity. They look for lower cost suppliers. If they've got control over your AVL, your approved vendor list, and you haven't specified that in your controlled documented product that we talked about earlier, they can go anywhere. They'll go to a low cost supplier and potentially squeeze some money out that way. They are always wrangling on payment terms. So ideally they'd like to get paid up front, and then they ship you the product in 3 months, and they've got that use of your money for that much time. The communication around purchase price variance, that's what PPV is, tends to be one way. They'll tell you if the price has gone up. So they bought their components and now it's more expensive. They'll pass it on immediately to you. If the price has dropped or they found a better deal, that doesn't necessarily get communicated right away. So you have to be very kind of on top of that and very kind of deliberate about communicating your expectations for passing those savings on. The time phasing of those cost changes, they would probably like to lag it, so that if there's a decrease, they'd like to lag and capture that for some period of time. And it's a negotiation. It's not unfair that if they're figuring out a way to cost down your product, that they should get some cut of that, but you don't want them to take it forever, right? You want them to pass it on to you. Talking about that up front is very helpful, and then it's all above board. So this is a little cartoon of Kelvin. The more sentences you complete, the higher your score. The idea is to block the other guy's thoughts and express your own. That's how you win. And that's often the way we talk to our suppliers. We talk at them. We don't listen to them. There's no back and forth. There's no conversation. And my recommendation is that you get your contract manufacturers passionate about what you're doing. They're just like us, right? They get excited about new ideas just like we do. Make sure that you advertise, that you market. You're a marketing person, right? Whether you're an operations person or a CEO or a design engineer, you need to market what you're doing to your suppliers so that they're as excited about what you're doing as you are. Make sure that they know what's going on with the company. Pass on updates with funding, with good customer successes. They'll pass that on to their team. Oftentimes, they'll pass it on to the workers on the floor when you're in town and talking with them, or if they're close by and you're in their facility. Make sure you bring up to speed the entire team, and you'll be surprised what kind of help that is to you. They're on your side. Get them T-shirts. They're on your side then. T-shirts are an amazing way to bring in your partners. Make sure that they're kind of on the same side as you. Make sure you know the highest level management that you can within the company. Obviously, if you're working with one of the big three, so to speak, Flextronics or Jabil or Foxconn, you may not be meeting Terry Gao, but you probably want to make sure you know the guy who's running the factory you're in. You want to make sure that when you're in town, you go out to dinner, you have a conversation about your business, you ask about their business, and there's a relationship established. Visit often, and we'll talk some about that as a kind of another delay possibility is that you're remotely managing. You want to be there. So moving on to another topic around delay is this idea of unrealistic schedules. Like I say, I'm sure none of you have ever done this before, but I've seen it many times where you create your little Microsoft project schedule or Smartsheet schedule, and it's you've got 1 day for releasing the product and 1 day for sending the BOM and 1 day you've got these little increments of time. There's not any kind of coordination with your partners. There's no conversation about lead times. There's sort of the then a miracle occurs in the schedule. I see some nods. Yep, we've been there. Tooling is a big one because I've seen this happen with a lot of companies that have plastic parts or metal parts, and they just don't think about the fact that they need to have a 2 to 3 month kind of lead time to get any kind of tooling. Obviously longer for the lower cost, higher volume kind of tooling. So those gotchas are going to they're going to surprise you, and then you're going to be delayed. And you don't want to be 3D printing plastic parts for volume manufacturing. I think even just understanding what it is you mean by DVT and PVT. Talk as a team. When we say DVT, we mean we've done a design review, we're frozen, we think we've checked, we've done the reliability testing, we're ready to go into manufacturing. DVT is a time when you're fleshing out your manufacturing process. You're ensuring that you can build the thing. You're figuring out whether there are any problems with volume. When you add variety to your material, you buy from multiple sources, hopefully that are on the AVL, that are in your BOM, but there's some variety, different time stamps for that material that you're buying. What happens when those things go together? What happens when your plastic parts are on the high side of your tolerance and your metal parts are on the low side? What happens when those margins kind of come together in volume? That's what DVT is supposed to figure out. You're supposed to build enough so that you know that when you get to true volume, you're not going to fall on your face. But if you're still designing, you're not going to really get there. And one of the big problems with scheduling is that you don't put any contingencies plans in there. You don't put any time in there for recovery. And this is a dilemma because I've worked with a lot of companies that really want to push the team. We really, really want to get this product out. We have to put the pressure on. We've got to make sure our investors are asking for us to launch. We've got to get this thing out by the Christmas season. So they put a very unrealistic schedule in place with sort of no opportunity for recovery. And then, shit happens, and there's no time to recover. It's a bit of a problem, and I guess you need to be kind of honest with yourselves as a team. Maybe you push for that aggressive schedule, but you do some what-ifs. Think about those what-ifs in terms of the financial impact, in terms of the seasonal impact or the customer impact. What if we get to, we're completing our engineering verification and we decide we need to do another spin? What if? What if that happens? Will we be able to, handle that from a customer commitment point of view, from a season availability point of view, from a cash point of view? So maybe you do that aggressive schedule, but you do some contingency planning so that you know what the consequences would be. And you're ready to kind of push that button if you need to. So the fourth delay challenge is sort of back to what I had talked about a bit earlier, sort of that remote control management. And this is I know this is a hard one for a lot of companies because oftentimes, we're in San Francisco and our contract manufacturer is in, I don't know, Huntsville, Alabama, or Shenzhen, China, far away. And you're so busy, you just don't have time to spend in China. And so, you send your PO and you cross your fingers and you hope for the best. And then you get the parts back and they're not working, and then you're, in big trouble. There are ways around this without necessarily dropping everything back at the home base. That's why OpsOnTap is in business. We do a lot of kind of that bridge between the contract manufacturer and the startup company to make sure that base is covered. You do need to have ops attention within your company. If you don't have an ops team, if you don't have manufacturing engineer, you don't have a supplier management contact, you don't have someone working in logistics, you don't have a lead there, maybe you think about buying some time from experts and bridge that gap. But don't ignore this, because if you hope for the best, as I explained with contract manufacturers, they're going to try to optimize for their profitability. There's a high probability that you won't get what you thought you were going to get. So make that investment. Have some eyes and ears on the factory floor. Make sure you set up those feed lines of information. Most good contract manufacturers will give you data on a regular basis. You should be there regularly, but even on top of that, make sure you get quality information coming back from them. Make sure you're understanding their yields. What you don't want to do is, show up, every few weeks, find out when you show up and you hadn't been there for a while that, half of your product is failing on the line. And now you've got this yield and availability issue. You want to know that as soon as it starts to happen, because probably something changed and there's an issue with your design. So you want to even maybe even have the conversation that if you start to see a higher failure rate than this band right here, you call me right away and put everything on hold. So you might have that discussion up front. But as you're ramping, you're not quite going to know what those numbers are. You want to be looking at that data. The other problem with remote control management of these contract manufacturers is that you're likely not going to get the best program manager on their side. And that means that things will fall through the cracks. They'll be on other projects. They won't be paying attention to the details. If you're there, it's hard for them to hide. So, being there, again, selling your company, talking about all the excitement. They know you care. They're going to care even more. Changes being cut in without qualification. That is whether you're there or not, an issue. You want to make sure that you don't just throw ECOs at them without having done the due diligence to make sure that they're going to work. You don't want to be learning that stuff on the line, especially if you're trying to build in a low-cost region, because they just don't, that's not what they do well. That kind of change and kind of chaos on the line will cause people to sort of stop caring, and that's that may cause a lot of quality issues. And this clean to build reporting, this is an issue of not knowing your material situation. So a clean to build is basically a report that tells you that you've got everything you need to build the product in whatever volume you have in mind. So if I'm going to build a run of 500, I ask for a clean to build report, and I may find out that I've got 2 or 3 parts that are missing. I understand when those things clear, and we have a conversation. Either we try to expedite those in, or we get partials delivered so we can start building. But having a good understanding of what's showing up when will keep you on track and will allow you to continue to build and not be surprised. All right, so we're going to talk about the disasters. Before we do, any questions or comments? Does any of this sound familiar? There's some nodding of heads. Okay, well, I'll keep going, but please think of your own stories, and we'll come back and share some of those. So the worse than delay is sort of disaster, and how can those disasters happen? The 3 areas that I've found kind of are the killers for startup companies are either an unrealistic model of your cost or sort of no model of your cost, cash not being managed, sort of no clear understanding of what the cash situation is and hoping for the best, and the third is a major problem with your customer base. So we'll go through each of those. Costs are not material alone. And I've seen that mistake made several times in companies where there's less experience perhaps with hardware products. The cost of goods sold, so to speak, of your product is certainly material, but it's also the uplift to buy that material. It's the labor, it's the overhead for that labor, it's the contract manufacturing company's SG&A, it's their profitability, it's warranty costs, logistics costs, packaging. So you have to think about all of the pieces that go into the cost of your product as you're considering your margins. And obviously your margins are going to be what feed you and make it possible for you to take less of that venture capital money. So you want to know what those margins are going to be, and at least with eyes open. So many companies have decided to go forward with 0 margin or even negative margin as they launch a product. Just because they need to show traction, they need to show enthusiasm, they need to get to that volume so that they can get those costs lower. But if you don't do that with open eyes, you think you've got a product that's going to make you money, that's what you've modeled, and that's what you've told your investors, and then you find, I get the bill from the contract manufacturer, and you've got to tape dollar bills every time you ship a product. Then you're potentially in trouble, and you're going to run out of money before you want to, or we never want to before you're thinking that you would. You're surprised. I think kind of goes hand in hand, but this issue of poor specs or poor product requirements can also be a fairly major tripping point. So you need to understand your customer environment, how your customers are going to use your product, and you need to have a good reliability plan in place, quality plan that will make sure that your product is meeting those major specifications. And we'll get to that a little bit more in a minute. But if you do run across an issue where you find that you've got to do a major overhaul of your product because it fails at temperature, or it fails in a humid environment, or the battery dies after an hour of use, or whatever, then you're going to have to redesign. You're going to have to go back to the drawing board, and that ends up costing a lot of money. You've got kind of, it's like changing a tire on a moving vehicle. You've got stuff in process, you've got material coming in, you've got lines scheduled, you've got customer orders kind of in place, and now you're trying to make a design change. That's, again, back to, do the EVT right, so when you're really ramping, you're ramping and focusing on operations. But as I said, things happen, unexpected things happen. So when those things happen, you want to make sure you stop, assess the cost, make sure you've got a good plan to roll that in, make sure it's a requirement, not just a want, and and do it with your eyes open with some planning. This whole quoting process, back to the challenge of a contract manufacturer, this quoting process is very important when you work with any supplier, whether they're major components or your final assembly contract manufacturer. You want them to quote transparently. And what that means is that they tell you how they're making money, basically. They tell you what their costed bill of material is. They tell you how they're marking up that material, what their labor rates are, what their labor rates might be in different locations, because sometimes there are different choices for where you build the product. You want to understand how much profit they're making. And they have to make a profit, and if you pound on them too much on that front, then they'll find some other way to make money. So you have to let them make a profit, and depending on what kind of CM they are and what kind of volume you have, it can range from sort of 3% to 20%. So there's all kinds of ranges there. None of those are unrealistic if it's depending on what the product is. So you kind of have to know your product and the CM kind of that you're working with and understand whether that's reasonable or not. But it should be open book. It should be something you can negotiate. If you think that they're getting too much profit, maybe you negotiate that down, or you put a plan in place to take that down over time. Look, when we get to the volumes we expect, we want that profit percentage to come down. It needs to be in the contract that way. And then, another challenge, of course, with the cost is, ECO hell, and that has to do with rapid changes and, unexpected changes. It kind of goes back to your specs and product requirements. And then kind of goes hand in hand. A big challenge, I think, to a startup company, and I've seen this happen, is that cash truly isn't modeled and managed. This is bigger than operations, of course, but in a hardware company, cash burns a lot faster. It's expensive. Tooling is expensive. Inventory is expensive. Ramping is expensive. So you can have a really good news story. I've got demand. I've got customers who want this product. But the bad news is I got to pay for it long before I'm going to get money back for it. So you want to make sure that you've modeled that cash cycle, and that's why that negotiation with your CM is so important, because if you can negotiate a 30-day term that kind of matches your payment terms, or is closer to it, you're going to have a much shorter kind of conversion cycle, cash conversion cycle, and therefore put money back into your pocket much more quickly in those ramps. Those up and to the right ramps are great for business. It's a really good news story for your investors, but they're not cheap. So you've got to make sure you know what you're getting into when it comes to hardware ramps and the cost. As I mentioned, think about that when you're negotiating the contract. Make sure your terms are in there. Make sure that you even have some kind of discussion early on about what will happen over time. I can say that most CMs are pretty nervous about the idea of extending credit line, extending too much credit to a startup company, because startup companies don't always work. They've seen it many, many times, and they want protection. They want to make sure that they're going to get their money. Sometimes bigger CMs are more willing to take that risk, but they've got to really believe in your company. Smaller companies, as I said earlier, can put them under if they do a deal with a startup company and that company doesn't pay bills, and that's happened in the past, and that's why some of them just won't deal with a startup company. But it's a negotiation, so you can start out with one term and move over time to a different payment term as your cash situation improves, either through an investment influx or through revenue and backlog. You can negotiate lines of credit with your bank or with your CM if they're big enough, if you've got a backlog. So there's ways of getting around that. I think this is the last issue here for kind of the disaster story is if you screw your customers. And this is maybe one of the most serious issues of all, and it happens a lot, frankly, that you kick off your company, maybe you have a Kickstarter campaign, you have early customers, you ship them that early product, and you discover that as you're charging your toy, your consumer toy, the power supply melts. And this is an example of a company I worked with. And it really wasn't the power bank problem. It was a problem with the wall wart. There wasn't a kind of a requirement to use a certain kind of power source. So you didn't have to use an Apple, or a Samsung adapter. You could use, off the shelf anywhere adapter, and that was very spiky, and it ended up melting the power bank. There were examples and stories coming back to this company of, the pictures of melted plastic. That's a really bad thing for a product that's going to kids. Now, this wasn't really young kids, but teenager or 13-year-old kind of age target, and it could have been a real company killer. But this company was all over it. They put everything on stop ship immediately. They took care of every one of those customers that called or sent examples on email and quickly sent them new power banks and with instructions for certain adapters. They actually resourced the power bank so it was able to withstand kind of the messy power that was coming in from the power source. And it cost them some money. I think the power bank itself was maybe twice as much money as the original one, but it was the only way to go because it saved their reputation. So social media is your friend, and it's also your enemy when it comes to stuff like that, because if you don't treat those customers right, that can just spiral up. Let's see, so how do you avoid that to begin with? Well, obviously, do the right reliability testing. You can do failure mean effect analysis to kind of think through all the things that could go wrong. The startup company that I was with built an end effector for a robot using electroadhesion, which is kind of a cool technology out of SRI, and it's the same kind of thing as when you rub a balloon on your head and stick it to the wall. That's the force we were harnessing for this adapter, this end effector adapter. And the problem that we had, it worked just wonderfully well in the lab. It worked fine in California. But when we got to humid China, where humidities are 95%, it rains in the factory and there's no air conditioning, the forces changed, and so we weren't able to pick up what we were able to pick up here in California. Well, shame on us. We should have done that environmental testing to start with, knowing what our customers were going to experience. So thinking about all of the possible failure modes, stress to failure, understand what your weak links are, through your this is a mantra I've sort of used throughout my career. Pay attention to your failures in your ramp process. Don't write those off. When you've got a failure in DVT, drive it to root cause. It's not a one-off. You may think it's a one-off, but don't go there. If you think it's a one-off and you ignore it, it's almost certainly going to come back and bite you. So just pay close attention to any failures you get as you start that ramp. take them seriously, drive them to root cause. And even if you can't roll in a change right away, at least you know about it and you can watch for it in the field. You can pay attention to what's going on with your data. Okay, enough said about that. Make sure that you've got the right kind of epidemic failure clauses in your contract with your CM. All it takes is one faulty solder joint, and something changes in your process. It passes in the factory, but then over time with shipment, vibration, et cetera, these things are failing in great volume in the field. I've got some nodding heads there. But if you've got an epidemic failure clause in your contract with that, it doesn't completely protect you because you still have a problem. You still have everything out there in the field that's not working. But the contract manufacturer has a responsibility. So you negotiate that they have the responsibility for the logistics costs. They have the responsibility for the repair and replacement of those units. And that's a negotiation. It's not always easy to get that through because they see that as a big liability. But you don't want to leave that unsaid because it happens. You want to make sure that you test in your user environment. The more customer exposure you can get to the product, the better off you'll be. You want to make sure that you're thinking about reverse logistics, or you could have some unhappy customers. So when you've got failures, what do you do about that? Do you ship them a new one? Do you ship them a new one ahead of them sending one back? How happy do you want those customers to be? Do you trust them when they say something's, they used it just with how the instructions said and it failed? Or do you push back on that? There's that kind of policy setting up front is going to make or break your customer happiness. If they get out there, if you have your product out there and they feel like you're not treating them well, that again, social media is a powerful weapon. They get that out there and you're not going to ramp the way you thought. And you want to make sure that when you design your product, and this is back to even before you build your product, that it's repairable. How are you going to, what's likely to fail? Can you swap it out? Can you swap it out in the field? Can you swap it out at the logistics center? Does it need to be, do you need to have a soldering iron to make a change? What are the ways this thing's going to fail, and what are you going to do about it when it does? Maybe you throw it out in the field, but that's expensive. So think about those things. Okay, so how to avoid these, this will be fast here. Internal, external strategies and striving for best in class. We've covered a lot of this already. So think about, in-house, think about a full cross-functional team. Have those direct relationships with your critical suppliers. Understand your supply chain. Even if you're, a design engineer, a CEO, a marketing person, know what your kind of the Pareto is of your components. Understand what your key components are, what those lead times are, what those costs are. Kind of get to know your product intimately. And last but not least, invest in operations. Whether it's an external person that you bring in, an expert like a consultant. That works, or an internal person, or maybe some combination of the two. Maybe you hire one or two experts that are inside your company, and you bring in some expertise if you don't think you need someone full time. But don't ignore it. External strategies, we covered all of this really. Effective contracts, negotiations up front before you start having them build product. The right kind of purchasing agreements with your component suppliers. So we focused on contract manufacturers. Oftentimes, you want to have direct contract and negotiation and conversation and connection with those key top suppliers on your bill of materials. So not just the contract manufacturer, but the ST Micros of the world, or the plastic molding suppliers, or whatever the big things are for your particular product. Negotiate costs regularly. Keep those things up front with your suppliers. Talk about it. Make sure they know what your plans are. If you start at $100 and you need to get to $60, make sure you're making that clear to your supplier, and you're including them in those plans, and that those plans are realistic. And then make sure that you put your people in the factory on the line. This is a picture of the Grab It line and some of our folks there on the line. And then, best in class cost, drive for the lowest cost and know what that is. Sort of do a costed BOM. And make sure that you don't accept something that isn't sort of best in class for your component pricing. Maybe you can't get there right away because your volumes aren't high enough, but you should be able to over time, and you can model that into your plan. So put those plans in place. Think about how you can take those costs down over time. Try to postpone payment and put those terms in the contract. That's cost, quality, what we've talked about before. Measure that quality, make sure you've got the data. You can even share kind of good quality results, kind of the benefit of that with your contract manufacturer, make them part of the solution. Make sure you know what kind of your product needs to withstand in the market, what's the expectation for your type of product, and make sure that it's going to work in the environment that you're selling into. Availability, similar, we've talked about some of these things. Know what your lead times are, know if you know what your effective lead time is and what your kind of total lead time is. So it's one thing to kind of pull in and get 10% more in the next month or 20% more. It's another thing to double your volume. So you have to understand kind of what the whole supply chain lead time is and what flexibility you have in that. Maybe even position some material if you've got some real long lead time components. So think about ramping up, ramping down, putting some positions in those contracts where you want them to carry some extra material, you want them to have some extra capacity. And then understand ahead of time what your liabilities are. Make sure you know what material is kind of non-cancelable, non-returnable, and that's stuff you're going to get stuck with if you do an ECO or your volume isn't there as you expected. Know what that is, and then also understand, maybe where you can return material so you can take a little bit more risk there. So, remember Alex. Great guy, amazing stuff, don't do this. This is much smarter. This is someone who's got the team behind her and using all the safety equipment, and hopefully, even if there's a little bit of a crisis, there's a recovery. Okay, so I went through my stuff. Now I want to hear something from you. What kind of stories, how about our head-nodding folks in the back, are some of these stories ones that you've lived? What are kind of the worst case, what are the bad problems you've had with ramp?
Okay. The main problem, I think, it's ever-changing requirements. So hardware takes longer than software to go into production, and during that time, there is new requirements that come from the salespeople, and then you need to make them work to also fit them in that product that you are already developing. So you always loop back a little bit or have to take 2 steps back. And how do you deal with that, or what's the best way to deal with that and lock, let's say, the requirements?
Yeah, well, you've got the right word. Yeah, and that's a pretty typical issue, because especially as you're learning about a market, you're going to learn about features and value for your customer. You got to kind of parse out what's a must and what's a want, right? You can't go to market unless you've met all the musts for your product. Hopefully, those aren't things you're discovering very late in the development process. Hopefully, you've done enough vetting and you've worked with enough customers. You know what the wants are. You know what the musts are. Sorry, I keep getting. You know what the musts are. Make sure you deliver those musts. The wants, on the other hand, can be rolled in over time with control. And I think that's the tension, in a big company and a small company, between engineering and operations, especially with software and hardware, but certainly with a hardware product. Marketing, the CEO, the investors, they want it now, right? But there's a cost to shoving in kind of features at the last minute. You're taking a risk on quality. You're almost certainly going to delay, even if you think you're really good and you're not gonna. You probably will. But maybe more importantly is that quality risk. And once you start shipping a product, you want to be in control. That doesn't mean you don't change. It just means you roll in those features over time. You cut them in as you understand your inventory implications, as you understand the cost of that. After you've done the qualification, you've built them in some volume and low volume, and you know that it's going to work with those new features. So you got to be, you got to have some process control inside the company, hopefully from the leadership on down. It's good information if there's some new features that are being asked for, but unless they're musts, unless they're requirements for the customer, you want to make sure you're rolling those in a controlled way. Any other stories?
So we had, we've had, like I said, we're shipping 3 products, so we've had some fun things. And I'm actually the software guy, so I don't know, I'm not deeply involved, like I'm not on the phone every night with the manufacturers or anything. But we had, for example, one time, one of our products plays music with MP3 files that are stored on an SD card. Mm-hmm. And we tested it all, and this goes to your testing thing, like we tested it all at work, and we ran it overnight, it all sounded good, so we got our first run, they're selling them on Amazon, they're going out to people, and we start getting reports that, hey, this sound stops working after a while. Mm. And it turned out they had gone to a lower quality SD card and gotten it from a cheaper manufacturer. Mm-hmm. I don't think we knew about it, or I don't even know if we really spec'd, what the card should be, but it turned out that with the type of power supply we were using, the card would burn out after a couple weeks. Mm. And so we ended up taking back the entire first shipment and hiring an intern in the office to unscrew them and put in a new SD card loaded with.
I bet he loved that job.
My kids actually came to the office one day, and my boss showed them how to run a script. Plug the SD card in the computer, run the script.
Your kids were,
they're like 12 years old.
Transcripted, right?
So do little things like that. So that was one interesting one that we had, and. But again, like you said, my founders are really very focused on customer service. So everybody got a new device, and everybody was converted to a big fan of ours, I think. Mm-hmm. But and then the other one that was interesting that happened is we were building another device that relied on a little circuit board that this CM made, and they supplied it for other very similar devices. And they sent us the specs. We designed our whole casing and everything, all the buttons and everything around that. And we're ready to manufacture, and we get the first prototype unit, and it doesn't fit. The circuit board's too wide. And it turns out they had changed their design, and they had sent us the old specs, which were 1.5 millimeters narrower than the new design. And that was a total shitstorm. I heard, my wife is actually from China, and so she interpreted a little bit on some of those phone calls, and I was, sitting there going, oh, man.
I didn't know they had that word in Chinese.
Yeah. It was some pretty tense phone calls at that time.
Yeah.
In the end, I think in that case, the CM eventually said, yeah, you know what, we screwed up. We're going to eat this cost, which, like you said, probably completely destroyed any profit they hoped to make on that.
Right. Yeah, but if they want to be in the business, they have to, and again, those are the things you want to have, that'd be an epidemic kind of failure. You would want it, or maybe it never went to the field, but that's the kind of thing you want in your contract. And to your point, you want, if you can have an AVL, put your AVL in place, along with your bill of material. Here, at least for the parts that have that are most critical to you. An SSD card is going to be something you'd want to say, these are the suppliers that are approved. And let them come forward with some alternatives. That's not a problem. They may have a low-cost alternative that you might want to consider. But don't just let them put it in. Try it. Let's build 10. Let's build 100. Whatever whatever your volume is, and make sure that it's not going to, screw up your power over time.
It's hard to think of all the testing. Like we had, consumer electronics products, and someone said, "Yeah, I set your product next to my heater." And I'm like, "Do we bake our product?" Product in an oven, right? It has to go in the bathroom with the shower running, 90% humidity, right?
Yeah.
So many different possibilities.
Right.
We actually put one in a freezer overnight and then plugged it in to see if it's still
working. And that's what that highly accelerated life testing, halt testing, is all about. That you break it. Basically, you take your product and you break it, and you figure out, it's not going to work at 150 degrees, or it's not going to work when the humidity is 95%, or it's vibrating at this frequency. So at least you know what your kind of your limits are, and if they're too close to your operating specs, then you probably have an issue. Yeah. Thank you. That was great. Any other stories? So how many people want to just build software products now? I asked the CEO, this is a company that's actually closing its door, so it was kind of a sad situation, but as hardware CEO, I said, hardware CEO, what would you advise other hardware CEOs now that you've gone through this? And he said, build a software product. So I think, it's a tough, I shouldn't end on that negative note. It's a tough thing to do, but I think, there are plenty of success stories, and when you can ship a hardware product successfully, it can build a great company, and we need more great hardware companies. And I really am not a fan of just, every company being software in the U.S. That's not the way to grow an economy. So keep going, good stuff. I think we're out of time, but if you have any questions, please let me know, and feel free to, send me an email or give me a call. Certainly be happy to answer any questions later on. So thank you very much.